Hello, and welcome to a revised presentation of my crew alert system for the Helicycle. I had hoped to make this brief, but it's turned out to take a little longer than I expected. I hope it's not too drawn out for you and that you find it of interest. At the end of the slide presentation, I have directions how to get to my website, how to find the PDF version of this, if you're interested in finding out more detail, and how you can contact me if you have any questions or comments. So thank you, and I hope you enjoy watching this. The CAS circuit board itself is capable of monitoring 15 different aircraft parameters. I've taken those 15 inputs and grouped them into 8 logical groups, which I'm calling channels. And the reason for that is to cut down on clutter on the panel. I didn't want 15 separate red indicator lights for every single sensor on the aircraft. The inputs typically are buffered by sealed miniature read relays. That allows a very small input current to control a much larger output current. So most of them will only load down the alarm circuit going into the board with a 20 milliamp load, and yet they're capable of driving a 1 amp output. In practice, in my application, these outputs are going to small panel lights which draw 80 milliamps, so nowhere near 1 amp. The contacts on these relays are actually rated at 2 amps, but I'm derating them here on this chart. The total current draw, the maximum for the entire board, is limited to 2 amps by an internal fuse. But in practice, you'll never get close to 2 amps. When you do a self-test of the circuit board, you will turn on every single relay and every single output warning light. If you're using 80 mil panel lights like I am, the total load during a test is 1.3 amps. So that 2 amp fuse is sufficient, and this board should be connected to a circuit that's capable of handling that 1.3 amp maximum load. So probably a 2 amp circuit breaker. And if it's in conjunction with other things, just add 2 amps to whatever you were planning in the first place. The logical groupings I'll go into in more detail. In terms of inputs and outputs that can go to this circuit, typical inputs could be chip detector, the clutch switch, temperature and pressure switches, various kinds of modules, battery low voltage warning module, a rotor RPM alarm, engine RPM alarms, and all of the various UMA custom Helicycle instruments that I sell. In addition, if you decide to go only with your stock instruments, the Westech fuel quantity indicator has a low fuel warning output on the back of it, which can drive an input on the circuit board. So those are typical inputs that can go to this CAS board. Output devices, incandescent lamps I think are the best. I would avoid LEDs, they're just not bright enough. Oral acoustic alarms. Also, there are some very inexpensive digital voice recorder playback units. So in addition to lighting a warning light and latching up my very bright sunlight readable Master Warning Annunciator, you could also have a voice playback unit that was saying warning, warning, and you could route that through your auxiliary input on your communication transceiver so that you would hear an oral alarm in your headset in case you were so distracted that 4 watts of bright red light in your face didn't attract your attention from the Master Warning Annunciator. So looking at this chart, I'll not go into too much detail, but basically there are two input types. Most of them are negative logic, meaning that a ground on an input pin indicates a fault condition. Channel 8 is the exact opposite. It takes a plus voltage to indicate an alarm condition. Most of the inputs, as I mentioned, are buffered, so the load on the input for most of them is 20 milliamps or less. Channel 8 is a 40 milliamp load. 5, 6, and 7 have no buffering, so whatever the output load is, that's what the load would be on the input. And typically I would use those for things like the clutch switch, chip detector, things like that, pressure and temperature switches, things that can handle a little bit of current that could directly drive a light bulb. And again, I'm rating all these things at 1 amp. The total load on the entire board should be limited to less than 2 amps. I have it internally fused to protect itself. So in practice, during a lamp test where everything is lit on the entire panel, including the Master Warning Annunciator, all the relays are energized. The load on this board, if you're using the same 80 milliamp indicator lamps that I am, would be 1.3 amps. I think that's enough detail on this chart. Now let's get down into the nuts and bolts. The crew alerting system, which I'll call CAS, consists of the logic board that you see on the left and a master warning indicator on the right, and also individual alarm indicators. And again, I'm using incandescent small lamps. The circuit board consists of 6 sealed reed relays, these black cubes here, and a bunch of silicon diodes and 1 fuse. So it's fairly simple, and I'll go through the circuitry and show you how it works as we go. Here's a shot of the instrument panels that I'm manufacturing for my Helicycle and for several customers. I use a lot of customized UMA indicators that I've designed for the Helicycle and have them manufacture for me. The 5 that are serving as input to my CAS are here in the center, right here. From left to right, we have fuel flow, transmission oil temp, engine oil temp, engine oil pressure, and exhaust gas temperature. The larger indicators have internal LEDs. I don't know if you can see them, but there's one right here for the fuel flow, and there's one right here for EGT. The smaller indicators, these 1 1/4 inch diameter ones, are not large enough to have an internal LED, but they all have alarm outputs that go to my CAS board. All of the legends are silk screened, again customized for the Helicycle. So the green, yellow, and red arcs are for our aircraft and our engine. Whenever you hit red, you have an alarm condition. 2 of the indicators actually have 2 alarms. This one here, engine oil pressure, I have a low and a high alarm, because too much pressure can also be an issue. We don't want to blow an oil seal out. Another one that you'll see in a minute is my voltmeter. I have a low and a high voltage alarm coming out of that guy. So those are the some of the input sources. The indicator lights are these dial light military stovepipe incandescent lights that I use. They take a T 1 3/4 flange light, which is an 80 milliamp 14 volt light, Comes out to about 1 watt. So we have 7 of them down here, 2 up here, low and high rotor on either side of Doug's dual tack. And then up at the top, right under the glare shield, where it's pretty hard to miss it, is my sunlight readable 4 watt Master Warning Annunciator. So even if you're looking outside, this should be in your field of view, in your peripheral vision. When this goes off, it will be very hard not to notice it. Now let's take a look. We'll drill down and we'll look at the center of the panel in this area here. Here you can just see a better look at the small 1 1/4 inch indicators in the middle of the panel. Transmission oil temp, engine oil temp, and engine oil pressure left to right, and 7 of the indicator lights down at the bottom. There's not too much to say about this. I really love these indicators. They use air vane technology. When there's no power, the needles drop straight down, as you see here, so it's pretty easy to tell if there's been a failure or a loss of power. One problem with stepping motor indicators is they just sit in the same spot. So if it was in the green when the power went off, that needle would remain in the green. These won't do that. Another feature of these UMA indicators is that they have 270-degree sweeps. A lot of the indicators that come with the Helicycle are 90 degrees. So even though these guys are small, you get a lot of resolution. They're very easy to see. The needles are big, fat, white needles. They're very easy to see. If you compare these with the stock ones that come with the helicopter, there's no comparison really. And then, of course, in addition, these indicators all have output pins in the back for the alarms. The only indicator that comes with the kit that has an alarm is the Westac fuel quantity. Then down at the bottom, those are the dial light indicators that I use. Each one's an 80 mil lamp. Comes out to about 1 watt. They're fairly bright. They have a wider field of view than LEDs, and that's why I went with incandescent. LEDs, when you look directly at them, a lot of these indicators look very bright. The problem is that these are not at eye height. They're well below, they're down by your belly button or your chest. And from the viewing angle that you would have sitting in your seat in the cockpit, the amount of light going up at that angle is not very good for LEDs. So they're very difficult to see, especially in the sunlight. These are much better, but you can also miss these. As you'll see later, that's exactly why I did all this. Is I had a low rotor warning and I didn't even notice it. The light was lit. It did not catch my attention, and that's why I wanted a Master Warning Annunciator that would be almost impossible to miss. Here's a look at the top of an unfinished lower instrument panel with 3 remaining UMA indicators that I use. On the left is fuel quantity. As with the other 2 larger instruments, this one also has an internal LED here for low fuel warning. It is a direct swap with the Westac factory fuel quantity, which is the only one that has an external alarm. So you could use that one. That would work. I just happen to like these instruments. They're much higher quality, but they cost more money. The second indicator that has 2 alarms is the voltmeter in the upper right. The first one was the oil pressure for the engine. So again, here we have a low volt and a high voltage alarms that come out the back of this one. Here's some of the input devices that you could use. The lower left is my rotor alarm, RPM alarm that throws out 3 alarms. These are solid state relays right here that drive those 3 alarms. and they are a low rotor, high rotor, and rotor red line. So those go off at less than 610 RPM, more than 620, and more than 635. And then if you didn't want to get UMA indicators, you could head down to the auto shop and probably find yourself pressure and temperature switches, which typically go for like 15 or 20 bucks. Those could just as easily be driving some of the inputs to my CAS, and they would work just as well as the indicators. And then in the upper right, this is a low battery voltage module that I found on the internet. I think it's sold for about $25 or $30. So there's ways around the approach that I'm using. I've tried to make the CAS board as open to alternative inputs as I possibly could. Here's some possible output devices you might want to look into. The one on the left is especially interesting. These things are available for less than $3 on the internet. It'll record about 8 seconds of audio with its built-in little microphone, and then you can play that back as a loop. On the right is a Mallory SonAlert, which is just one of several different kinds of oral acoustic alarms that are available. The one I'm using puts out a steady tone, and it's very, very loud. And this travels through the air. It doesn't. It's not a signal coming out of a wire. It's loud enough so that I can hear it even with my Bose noise-canceling Aviation X headset on. The one on the left has a speaker output. You see that little green guy up in the upper right? That's where the speaker wires would go. What I would do if I were using this is I would record, or have somebody that has a really good voice record alarm, something like that. It'll record up to 8 to 10 seconds of audio, and then run that into my aux input on my communications transceiver. Usually there's an intercom feature on most of the modern ones. That way it would come through your headset. You'd need to do a little work to tailor this to make it actually function. You'd need a 5-volt regulator and a couple resistors probably, nothing fancy. You'd have to wire up to where those little push button switches are and hook that up to my CAS unit. But that would really be handy. So even if somehow you miss the 4-watt annunciator at the top of the panel, you would hear a warning in your headset. Here's a circuit diagram of the CAS circuit board. Depending how YouTube decides to compress this, you may or may not be able to actually read it. But don't worry, I'm going to zoom in and go over this in detail in a second. The way I've laid this out is all of the output devices are over here. And in my current design, they're all incandescent light bulbs. All of the inputs are over on this side. And that's probably enough detail on this schematic. Now let's drill down and see what's going on. Here we are looking at the top of that schematic from the previous slide. Again, we've got 15 inputs, which I'm trying to declutter. So in these 3 channels, I've got a total of 8 inputs over here, which are driving 3 outputs: engine, transmission, and voltage. For engine, I'm looking at high engine oil temperature, low and high engine oil pressure, and exhaust gas temperature red line. So any one of those 4 inputs will drive this engine alarm if there's a problem. Down here I'm taking 2 inputs to drive 1 output: high transmission oil temp and high fuel flow. The reason for the high fuel flow being associated with the transmission, it takes a little explaining. You'd think maybe that should go with the engine. The transmission has a torque limit of 160 foot-pounds on the input shaft. There's no practical way to really monitor that parameter. It's too difficult. But fuel flow is directly proportional to horsepower, which is related to torque. And so by doing the math and doing some flight testing, I was able to come up with a fuel flow limit which will approximate the torque limit on that input shaft. So that's what I'm doing there. For the third channel, voltage, I'm looking at both high and low voltage warnings. So that's the way that I'm cutting down on clutter, taking those 8 inputs, reducing them to 3 alarm outputs. Notice up here that there's a lamp test. This is a momentary push button, which is actually part of the Master Warning Annunciator. It's an illuminated push button switch, really. So when you push on that annunciator, it sends an input to every circuit on the cast board. It will energize every OR gate, every buffer relay, and illuminate every single output device. So it tests all the wiring, all the input circuitry, all the relays, all the indicator lights. So you would typically push that lamp test during your pre-flight, and that would ensure that the circuit was operating properly and that all of your indicators were functioning. Notice also that each one of these channels has an output heading down this way. Now let's see where that goes. Now we're down at the bottom of that schematic. Here's all of the lines coming from each one of the individual channels to one common OR gate. Over here off the picture is my rotor RPM alarm. It's got 3 outputs: low rotor, high rotor, and rotor red line. Those outputs are ORed into one common output. That output then goes along with all the other outputs from all the other channels to this master warning OR gate. So if any one of the 15 parameters starts to throw a fault condition, this relay will get latched. This relay in turn drives the Master Warning Annunciator, which has 4 bulbs inside of it. Since it's a latching relay, this annunciator will stay lit even if the fault condition is a transient and it goes away. And that does happen. So if you're looking outside, you notice that the Master Warning Annunciator is lit. You look down at the individual alarm lights and none of them are lit. That tells you that there was some sort of a transient fault condition, but now it's cleared itself. So that would indicate that there's a need to increase your vigilance, pay attention, see if it comes on again, and then deal with it. Notice up here there's a reset button. This is a momentary push button. On my ship it's going to be on my cyclic grip. This is how you'd reset that latching relay. So once you've determined what's going on, you can shut off the Master Warning Annunciator, assuming that the fault condition has gone away. If the fault still exists, pushing this reset button will have no effect. This is probably too small for you to read, but if you purchase one of these from me, this is what you'd use if you were wiring it up the same way I am, using all of the UMA indicators. If you're not, you can substitute. And I think I've shown you enough detail here so you can figure that out. If not, drop me an email and I'll explain how to do it and help you through it. I should take a moment to explain why I'm doing this in the first place. I have a video on YouTube that's called Monterey Bay Shoreline by Helicopter, or something like that. You can find it if you search for my N number, N750 Golf, or that title. You'll probably find that video. Way at the end, you'll see that I start climbing out after I pass a sunken ship. And if you look closely at my panel, you'll see that my low rotor warning light comes on. It's the one below and to the left of Doug's dual tack at the upper right of my instrument panel. That was all well and good. Everything worked perfectly. It was indicating that my belts were slipping. There's only one problem. I didn't see that until I was editing the video sitting here in my shop. I never noticed that light was blaring away at me. So clearly I either had to improve my scan, get some new glasses, or change the way I operate the helicopter. Since none of those really seemed likely, I started thinking, well, how do the big boys deal with this? I've got a background, 5 years as an airplane mechanic for United Airlines, 2 years working on the Lockheed U-2 reconnaissance airplane, supporting one of its sensors, and 5 years of flying around on a NASA research airplane. So what's that, 12 years of experience with the big iron, basically. And one thing that's common to all of the airplanes that I've ever worked on, all the Boeing airplanes, a couple Douglas, the Lockheed planes, they all have a Master Warning Annunciator up at the top of the instrument panel or the glare shield. And so I decided that's the approach that I wanted to take. That led me to a multi-week search trying to find a suitable indicator. None of what's called COTS, commercial off-the-shelf indicators, are sunlight readable. They just don't exist. And the companies that make these things usually support only the airline manufacturers and the military. Everything is to very, very high standards and extremely expensive, and they're all custom made to order. So that put that source completely out of the picture. Just to get a small quantity would have cost me at least a piece price of $1,000 per Master Warning Annunciator. So in desperation, I started searching on the internet. I got on the internet, and I actually found military surplus source for the annunciator that you see in this picture. And these are brand new, sealed military surplus. They came, I believe, off of a P3 Orion Subhunter. If you look at that part number on the bag, you can actually Google that and you can find some information. These things originally sold for about $1,000 a piece. I bought the entire supply that I could find, which consisted of 9 of these. And there are no more, as far as I know. I think I got all the ones that existed. I have 4 that are promised already, and probably a 5th. And I'm going to keep one as a spare, so I probably have 3 of these annunciators that I can pair up with my CAS board and sell. So if you're interested, give me a call and I'll set one aside from you. Once those are gone, I doubt very much that I'll ever be able to find any more annunciators that are good enough for this application. I can make lots of the cast boards, but without this, it's not worth the trouble. Here's the individual components. The way these mount is through a rectangular hole in your instrument panel. You'll see that there's a lip over on the left right here. So the cutout has to be accurate enough so that it's hidden behind this lip, obviously. You then slide this in till the lip butts up against the front side of the panel. Then you slide this piece over this, flush up against the back side of the panel. Following that, this piece goes on, pushes up against this one, forces it up against the back of the panel. Lastly, you take this screw, it goes through a hole right here, goes along the side of the switch and engages some threads down in here and pulls this whole assembly tight, forcing this part against the back of the panel and pulling this lip this way and wedging it from either side so it's locked onto the panel. Beautiful. This is the rear of the back side showing the individual contacts for the lights and the push button switch. And I've got a red arrow that's pointing to that screw. So that's the screw that pulls the whole assembly together and locks it on the panel. These units relamp from the front. So to put, if you burn out a light on the front, and there's 4 of them in there for redundancy, you don't have to tear into your instrument panel. You push on that little bitty tab that you can see pointed to by the white arrow. Push that over about 1/8 of an inch, and that assembly comes out from the front. This is the back side showing the cells where the 4 lamps go. These lamps are called flanged T1 3/4 lamps. These are, as I say, they're 80 milliamp 14 volt lights. So if you add that up and do the math, you come up with around 4 watts of light with all 4 of these going. It's very, very bright, and you can easily see it in the sun. Here's the mounting information and size of the cast logic board itself. It measures 3.8 inches by 2.5 inches. It mounts using 3 standoffs, as you see, 440 standoffs. The red dashed circle in the middle is a clear area that measures a 1/2 inch in diameter. So if you're using a socket or some other tool, as long as it doesn't extend outside of that little dashed circle, you're not going to damage the board. There are no components within that 1/2 inch diameter clear area for the center. All of the inputs and outputs come through the top to a 37-pin D sub-miniature connector. So what I'm offering as part of this cast is this populated circuit board ready to go, and mating connector, and the Master Warning Annunciator. All the panel lights and whatever other input or output devices that you'd care to use, that's all up to you. And I'd be more than happy to help you with that. And I'd be really happy to sell you some really high quality customized UMA indicators that are designed specifically for the Helicycle. Okay, finally reached the end of my presentation. I promised you it was going to be short. My apologies. I hope you didn't fall asleep. To get to the PDF version of this, which has some more detail, actually quite a bit more, on how I would wire this up if I were using all the UMA custom indicators that I'll be using, you can go to my website, www.helicycles.org. Up at the top there. pull down the menu tab on the right, which says My New Helicycle. Select the New Construction Log menu page at the bottom of that one. And then you'll see a great big list of all of the PDF files for all the various things I'm doing at the moment. Find the one that says Crew Alerting System and Master Warning Annunciator, and that will bring up the PDF written version of this. If you'd like to email me, my address is juan@helicycles.org. Thanks for watching.